In this video, I want to go over a few CLEP college algebra concepts. Last week, we had worked through some of the concepts from chapter 4, which is in the REA college algebra book. And today I'm going to go over a few more items from that section, actually. So we talked about the applications of functions. We talked about the composition of functions. And those are videos you can go back and watch, but I'll try and assign you some practice problems after doing those, okay? So we ended on page 89 with the applications. Actually, I apologize. On page 89, we did the applications of functions, and then we moved on to the domain and range discussion, which happens all the way into page 90. Let's actually pick it up from there today. We're going to start with the interval notation, quick review of that. We talked about the idea that there's less than and greater than, less than or equal to, greater than or equal to. There's open circles, there's parentheses, there's brackets. And so these are things that we discussed in our college algebra review. So please go back and watch that if you need to. You will have time today to go over those things that we did. So we discussed those in class. I'll make the videos available to you. Please watch them, and then your assignment today would be to answer specific questions that are based on the video that you're watching. So the domain of a function is the set of allowable x values as described earlier, as we talked about. It's the x values of that function. Now we printed out this document, which you should have available to you, and in this document it basically goes over different things that any math student should know. And one of the pages focuses on domain and range. It says graphs of parent functions, and you will notice that the first function there is called the linear function. The linear function has a domain from negative infinity to infinity. Meaning that any value you plug in will be fine, right? So y is equal to 2x plus 5. So that's a linear function. Any value of x is allowable. That's the idea of the domain of that function. Not every function has a negative infinity to infinity domain. So basically, the domain in this case is negative infinity to infinity. The range is also negative infinity to infinity. What that means is that if you were to graph something, okay, and I'm just going to sketch this graph, okay? I'm sketching a graph and it intercepts at 5. That means that you can go forever to the negative infinity value, and you can go forever to the positive infinity value. That's what it means, okay? That's what the domain of that function means. If I drew another graph, and it goes like that, notice that the domain, it would have to start from 0 and then go to infinity. That's the nature of the domain of this particular function that I have on the right side of the board. So please keep this handout, right? You're going to have a handout, like a document to go back to and review. This is important, having a document that you can use to review things in the future. It's very important that you keep building on your study skills, that you keep applying yourself to know how to use your resources. That's part of what makes people excel in the work world, is knowing how to use their resources, okay? So let's move on here. We basically have the domain and the range discussed on page 90. And I give you a few examples of functions and ask you that to find the domain. The first example is a polynomial, x squared minus 3x minus 1. That is a polynomial function, and there is no value of x that you plug in there that's going to be a problem. So the domain is all real numbers. That's the first one. For the second one, there is a domain restriction because it's 4 divided by x plus 2, right? So in the second example, it's 4 divided by x plus 2. In this case, the domain is all real numbers except negative 2. Because if you put negative 2 in for x, it will cause that to have a 0 in the denominator, which is a problem. So the domain is basically all real numbers except negative 2. The third example they give you is a similar situation. However, you have to factor that polynomial first. So please, if you're with your REA book, we'll turn to page 90. And we're looking at the third example. It says f of x is equal to 2x divided by x squared plus x minus 20. In that denominator, you have to factor the polynomial, which will become x plus 5, x minus 4. set that equal to 0, and then you basically say the domain is all real numbers except -5 and 4. Okay, and please write out these examples here in your notes that I'm giving. So we're looking at the domain section, page 90, and we're going to write out those examples. The fourth problem is the square root of x minus 8. Now, if we're dealing with real numbers here, right, then we can say that the domain of f of x, which is square root of x minus 8. So in this case, the domain would be values that if I was to substitute in, right, would give me a positive radical. So if I put in 8, I would get 0. So I know that my domain would include 8, which is fine, and any number above 8 will be fine as well. So the domain is basically, you take the number 8, and it'll be just fine, and any number above it. So the domain is x is greater than 8 and above, because you don't want to have a negative square root, right? So that's the idea of the domain in D in this problem. So the domain is x is greater than 8, greater than or equal to 8. A range of a function is the set of allowable y values of that function. So we talked about the domain, and now we're looking at the range. So the range can be determined visually as the lowest possible y value, right? If you look at certain functions, like let's look at a quadratic function. If we look at a quadratic function, y is equal to x squared, something like that, the range would be basically going from 0 to infinity. Okay, so the range would be going from 0 to infinity. Okay, and we'll actually write it like 0 to infinity for the range. Okay, so we have the domain and the range, and then they give you a quick example there. That one of the best ways to find this domain, to find this range, is graphing, sketching the graph, or having an understanding of that graph. And this is why this document is very important, because it shows the graphs of the parent function. It's very important that you know that, okay? So, domain and range, very important topic. So then the example on page 91 says find the range of f of x is equal to 4 minus x squared. Since the smallest value of x squared is 0, the range of the function is -infinity to 4. So if you were to graph 4 minus x squared, then you would notice, and I'm going to sketch it. This is actually a good time to talk about graph transformations. So this is the graph of y is equal to x squared. What about y is equal to 4 minus x squared? It's the same thing as -x squared plus 4, okay? So first thing to realize is when you have a negative in front of that quadratic, is that it's going to actually become like that. It's going to flip, right? So that's the first thing to realize. So if someone says, what is the graph of y is equal to x squared? You would do that. Okay, that's the graph of y is equal to -x squared. I apologize, that's what I mean. If somebody says, what is graph of y is equal to -x squared? That's what we would say, is this. But what about y is equal to -x squared plus 4? You literally move that graph up 4 times. And now that is the graph of y is equal to -x squared plus 4. Notice that the problem started out as 4 minus x squared, but I was able to change the order. And that's okay because of the commutative property of addition. You can move around things that are added to one another. So the range of the function then is from 4 down to -infinity. So, or sorry, you could put it the other way around, -infinity up to 4, right? So basically the range is you're coming from -infinity and you stop at 4. So the range of a function, if it's like this, is everything from this point down. That's the range. But the way we would write it is we would start with -infinity and then we would write down the 4 on the other side. So that's how we find the range of the function. So we have the domain and then we have the range. Another example they give you is find the range of f of x is equal to the square root of x plus 1 and then plus 1 outside. That graph, again, you can sketch it on using Desmos calculator. So please make sure that you always have access to Desmos calculator. Okay, so Desmos calculator. Okay, So that's the domain and range section of the book. I want you to write those examples out for page 90 and 91. And if you have questions, please put an asterisk so we focus more on that later. The next section in your book talks about linear functions. So this will be a good breather. Oh, let's take a break for a second. So the types of functions that appear most frequently on CLEP exam are linear functions. So that's good news. This is chapter 2 of our Tyler Wallace book, and this is good news that they're linear functions. The graph of any linear function is a straight line. And remember, we use y is equal to mx plus b for the general slope-intercept form of the equation of a line. So that's the first thing to keep in mind. The linear functions, we start out with remembering the slope-intercept form, y is equal to mx plus b. But what is m? M is the slope. And what is the formula for the slope? It is rise over run. So it's change in y over change in x. So why don't we do a couple of problems with slope formula for a second? So basically the slope formula is y2 minus y1 over x2 minus x1. So the slope formula is y2 minus y1 over x2 minus x1. So they've given you a picture on page 92, so please follow along with me on page 92. They've given you a picture there, and basically they've given you some values in the next example of 2, 3, and 4, 7. We can do this for any set of points. So write out the examples they've given you in the book just so you have them, but let's use a different set of points. So if we have negative 5 and 7 and 8 and 10, and someone says, what is the slope? We label the first set of points, or it doesn't matter which one you choose to label as x1 and y1. You just have to make sure you're consistent. You label one of the points as x1, y1, and the other one as x2, y2. So you label it as x1, y1, and x2, y2, and guess what? You plug in the values. You plug in the values. That's the next step. So basically you label the points, and then we go ahead and we plug in the values. Once you plug in the values, that will give you the value of the slope, right? So please, for what I want you to do at this time is make sure you write out the examples on page 92, write the title clearly, and then give that formula, rise over run. Here's the formula, and then write out those two examples they've given you, and then finish out this problem here. So basically you have 3 slope problems that you would have completed. Okay, very good. So this is part of this goal, is just teaching us how to be organized and take notes. Now let's move on to horizontal and vertical lines. So generally speaking, with a lot of these equations that you're going to be doing, the y is equal to mx plus b is standard. You're going to get a graph of those types of values. But what if somebody comes to you and says, please, what is the value, or what is the graph of y is equal to 5? Right? That would be, you basically go to 5 on a graph. If somebody says y is equal to 5, you go to 5 and you draw a straight line. That's a horizontal line. So y is equal to 5 is a horizontal line. But what if somebody says x is equal to negative 4, or x is equal to negative 2? Graph that. Well, basically you go and you graph it at that location for negative 2. Or you go to that location and graph it at negative 4. Do you see how it kind of works? So that's how vertical and horizontal lines work. So y is equal to mx plus b is a general slope-intercept form of the equation of a line. But then we also have the horizontal and vertical lines, which can simply be denoted as y is equal to something or x is equal to something. So please keep that in mind as you work through your work. So I'll stop at this point, and then in the next video, we'll talk a little more about the different types of equations of a line. Thanks, and keep up the good work. Keep taking excellent notes.